Hello there, and I'm going to teach you how to do differentiation. What is differentiation? Differentiation is working out how steep of the graph, like the gradient. So, let's say a graph. You plot a graph of an equation. For example, y equals x plus 1. The differentiation will work out how steep steep the line of the graph. It will also work out the rate of change. The rate of change is the same thing, whether it's a negative rate of change or a positive rate of change, meaning positive rate of change would show the quantity between the values on the graph, as in, for example, the x across the x-axis as time increases, on the y-axis, whether it's a quantity, for example, of money. As time increases, your money increases. So that would be a positive rate of change. Negative showing that the slope, when you draw a line of best fit on the graph, it will show a slope going upwards, because as time increases, so does your money. On the flip side, as time increases, maybe your money drops. So that will show a negative rate of change showing. And then when you draw a line, it'll show the line will be going on a downward slope. So that's what differentiation is using to work out the gradient of a graph and the rate of change, which both mean the same thing. Differentiation is important because it's important to learn and master and utilize, because if you're going to go into maths, whether it's studying at university or college, or especially in college, you need to know differentiation because it appears everywhere in the exam. And if you don't know perfectly, if you don't know it at the back of your hand, you're in for trouble. Let's just say that, because you need to be able to differentiate on the spot. You need to know the laws of powers, chain rule, so on, product rule, so on and so forth. We're just going to go into the power rule. So let's go into our first rule here. This is the power rule. So y equals xn. So to work out the derivative of y equals xn, you multiply the x by the power, i.e. n, and then you subtract the power, n, by -1. And there you have worked out the derivative. There you have differentiated you've differentiated x to the power of n. These are two ways it can be written out. For example here, d over dx, bracket, open bracket, x to the power of n is equal to nx, n minus 1. We can write or dy over dx, the y representing the y equals xn, hence y is written like how it is in the first example here. That's why it's written like this. But typically in exams, and when you're working with differentiation, you write it like this: dy dx, because you're going to be asked questions where it might just say find dy by dx of x squared. So you're not going to write as d over dx and then put in the actual what y is equal to, and then work out like you're going to write dy over dx and you're just going to differentiate it like that. So let's move on to the first question. Y equals x squared. Differentiate y equals x squared. So we refer to our rule. We multiply by the power. So when y is equal to x to the power of n, to find the derivative of this, to differentiate it, you multiply x by the power of n, and then you subtract the power of n by -1. So y is equal to x squared dy dx is equal to, so we're going to do it like this, so nx, so because nx n minus 1. So we're going to do 2 multiplied by x. So you get 2x because we're multiplying the power by x. So you get 2x. But then we're also subtracting the power by 1. So 2 minus 1 is 1. But you don't leave it like that. You just write dy by dx is equal to 2x. You don't write dy by dx is equal to 2x to the power of 1. You just leave it on its own. You'd write as dy by dx is equal to 2x. And there you've differentiated your first question. Let's move on to the next question. Here we are dealing with two terms. Differentiate y equals 3x squared plus 4x. With differentiation, it's the same thing. You just, when it's dealing with equations, they're just made up of small little terms, as you can see here. So the same thing like how in the first question we just dealt with one singular term, just treat every term like you're dealing with one on its own. But in the end, they come together as one question, as one answer. So y equals 3x squared plus 4x plus 4x dy by dx. So let's deal with 3x squared first. Multiply by the power. So 3 multiplied by 2, you get 6x. Then you subtract the power by 1. So 2 minus 1, again 1. We just leave it as 3x. Let's move on to our second term, 4x. 4x is the same as writing 4x to the power of 1. So you multiply 4 by the power of 1, which is 4. And then you subtract you subtract the power of 1 by 1, which is 0. So it'll be 4x to the power of 0. But you're not done, because anything to the power of 0 is equal to 1. So therefore 6x plus 4 bracket x to the power of 1, x to the power of 0 is equal to 6x plus 4 multiplied by 1, which is 6x plus 4. And there's your answer. 3x squared plus 4x differentiated is 6x plus 4. Third question. Find the gradient of y equals 5x cubed, or to the power of 3 you could say, but we'd say cubed, minus 2x plus 1. As I mentioned at the beginning of the video, differentiation is about finding the gradient of a graph. It's finding the slope, how steep it is. So this is, when you're asked to find the gradient, it's the same as doing the differentiation. So it's just asking you the same thing, but it's written in a different term. That's why it's important to really understand and know differentiation, because it can be asked in different forms. Find a derivative, find the rate of change, find the gradient of. They all mean the same thing. Differentiate the given question, the given equation. So, okay, we're going to do the same process we did with the first two questions. Y equals 5x to the power of 3 minus 2x minus 2x to the power minus 2x plus 1. When we differentiate that, same process, we multiply by the power, and then we subtract the power by 1. So let's deal with 5x to the power of 3. 5 multiplied by 3, because 3 is the power, you get 15. And then you subtract the power, 3 by 1, which is 2. So it'll be 15x squared, or 15x to the power of 2. Deal with the second term, minus 2x. Differentiated. Minus 2x is the same as writing minus 2x to the power of 1. Just like with the first question, when we did plus 4x. Same process. We multiply by the power of 1. So minus 2 multiplied by 1 is still minus 2. 1 minus 1 equals 0. X to the power of 0, as I established in the previous question. Anything to the power of 0 is 1. So that will be 2 minus 2 multiplied by 1, it will be minus 2. And here's this question, plus 1. Now 1's a constant. But writing 1 is the same as writing as x to the power of 0. See it as that. So when you're differentiating, you'd write it like that, x to the power of 0. Same process, let's say we're differentiating x to the power of 0. We multiply 0 by the power, so 0 multiplied by x, anything multiplied by 0 is 0. 0 minus 1 is minus 1, but again, it doesn't mean anything because in the end, anything multiplied by 0 becomes 0. That's why this 1 differentiate just becomes 0. Just like how any singular term, if it's any integer on its own with no variable, with no attached to it, will become 0. Because it hasn't got an x, it hasn't got an extra power of anything. It's just on its own. It's a term on its own. So just like how 35 differentiated will become 0, 2 differentiated will become 0, 6,678 differentiated becomes 0. dy by dx is equal to 15x to the power of 2 minus 2. And there's your answer. Next question. Y equals 1 over x cubed. This is when we are dealing with negative powers. You're probably wondering, how will I be able to deal with this? When you're dealing with negative powers, I'll show you why this fraction is actually a negative power. Because when you rewrite it, 1 over x to the power of 3 is actually 1x to the power of minus 3. That's the same. So when you rewrite it, that's how it looks. That's why it's actually a negative power. So y is equal to x to the power of minus 3. And we just do the same process how we did with the other questions. We differentiate, we multiply by the power, and then we subtract the power by 1. So minus 3 multiplied by x is minus 3x. Minus 3 minus 1 is minus 4. But we are not done. we need to put it back into its original form, i.e. as a fraction, how we found it. So dy by dx, because it's a negative power, you would rewrite it like this. Minus 3 over x to the power of 4. And there's your answer. So dy y equals 1 over x cubed differentiated is minus 3 over x to the power of 4. Next question, differentiate y equals the square root of 2x. So when we're dealing with fractional powers, if you refer to my video, Simplify Surds, you might already know what the square root, what that's the power of. A square root is the power of a half. So we rewrite it as y equals 2x to the power of a half. And the same process as we did with the other questions, we multiply by the power and then we subtract the power by 1. So dy by dx is equal to 2 multiplied by a half, 1, x, a half minus 1 will be to the power of, so half minus 1 is minus a half, so it'll be x, so it'll be 1x to the power of minus a half. If you remember what I just done with the previous question, you would know that we're not done yet. So when we're dealing with negative powers, we have to put it back how we found it. So how we found the question originally, it was in the form of a square root. So we put it back how we originally found it. So 1x, we'll just write it write as x to the power of minus a half so we rewrite it as 1 over the square root of x. That's how you rewrite it. So y equals the square root of 2x. Differentiated is 1 over the square root of x. Final question, find the derivative of y equals 7x cubed plus 5 over the cube root of x minus 6 over x to the power of 2 plus 2. Don't be alarmed. As you can see, if you look at the previous question, we've dealt with these terms in these formats. So just because they're now all formed into one big equation, the process is the same. Differentiate, dealing with each different term, and those two can all come together. Of y equals 7x cubed plus 5 over 3 cubed root x minus 6 over x squared plus 2. Same process, differentiating. Actually, let's rewrite it, all the terms correctly. So y equals 7x to the power of 3, 5x to the power of minus, because when it's a denominator, that's a negative power. So minus 1 over 3. because cube root is to the power of 1 over 3, just like how a square root is to the power of 1 over 2, minus 6x to the power of minus 2 plus 2. See, now we can properly differentiate it. Now they're in terms where we can actually calculate it, and then we can, once we have worked it out, we can put it back into this format, how we originally found it. Let's deal with the first term. dy by dx. So 7x cubed differentiated, multiplied by the power, and then subtract the power by 1. So 7 multiplied by 3 is 21. X cubed, so to the power of 3 is 21x. So 3 minus 1 is 2. So it'll be 21x squared. (21x squared) plus, no, not plus yet, hang on. We multiply by the power first. So 5, positive 5 multiplied by minus 1 over 3, you'll get minus 5 over 3 x minus 1 over 3, so we subtract the power, we multiply by the power now, and now we subtract the power by 1. So minus a third minus 1 will be minus, pardon me, it'll be minus 4 over 3. Let's move on to the next term. Minus 6x to the power of minus 2. We multiply by the power first. So minus 6x multiplied by minus 2 will give you positive 12x. Then we subtract the power by minus 1. So minus 2 minus 1. So it'll be to the power of minus 3. And then positive 2 differentiated is just 0, as I've mentioned in the previous questions. So now we deal with these 3 terms. So that's it differentiated, but we need to put it back into how we found the question. That fraction format, how we originally found it. We can't leave dy by dx is equal to 21x squared minus, this is going to be a long one, 5 over 3 cube root x to the power of 4 plus 12 over x to the power of 3. And there's your answer. And that is the basics of differentiation using the power rule. Thank you for listening, and goodbye.